Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. Now we also have a little chart here for you. 1 milliwatt equals 0 dBm, 10 milliwatt equals 10 dBm, 100 milliwatt equals 20 dBm, and 1 watt or 1000 milliwatts equals 30 dBm. These can be some good starting points to memorize, because many times when you're doing RF math calculations, you can go ahead and jump to a number you already know and then go from there. So for example, if you already know that 20 dBm is 100 milliwatts and you're trying to figure out, well, then what would 23 dBm be? Well, if you already know what 20 dBm is, you don't have to start with 0 dBm as 1 milliwatt, because normally if you're going to try to figure out what is 23 dBm, you could use the rules of tens and threes that I'm going to talk about momentarily and calculate it. But you'd first have to do 10, then another 10, then a 3. But if you already know 20 dBm is 100 milliwatts, then all you have to do is add 3 dB, and that's going to double it, so it'd be 200 milliwatts. Let me talk to you about that. Here in the screen, notice where it says gain and loss examples. When we're talking about the rules of tens and threes, what we mean is that if you add 3 dB of power, you double the power. If you subtract 3 dB of power, you half the power. So this is the 3 rule. So if I have 50 milliwatts and I add 3 dB of gain, I now have 100 milliwatts. But if I have 50 milliwatts and I lose 3 dB, or I have 3 dB of loss, now I have 25 milliwatts. Okay? So the 3 rule: add 3, multiply by 2, subtract 3, divide by 2. Then there's the 10 rule. If you add 10 dB of power, the signal strength is 10 times stronger. If you subtract 10 dB, the signal strength is 1/10 or 10%. So let's go back to our 50 example. 50 milliwatts plus 10 dB is 500 milliwatts. 50 milliwatts minus 10 dB is 5 milliwatts. Okay? So these rules of tens and threes can be used to calculate your power levels, and we're not going to get into complex examples today, but I want to make sure that that's introduced and understood here. So again, going back to our example of, I need to know what 23 dBm really is in milliwatts. If I already know 20 dBm is 100 milliwatts, then all I have to do is add 3 dB, right? And when I add 3 dB, what do? I double it. Therefore, what we have is that our 100 milliwatts becomes 200 milliwatts.